In this question, we have a circle with center O and radius r centimeters, has a sector OAB of fixed area 10 square centimeters. Angle AOB is theta radians and the perimeter of the sector is p centimeters. In part A, we want to find an expression for p in the terms of r. The first thing we can do is write down a few formula which may be useful. So we have the arc length, which is S equals r theta, and r is in radians. The area A equals a half theta times r squared, or alternatively, we can write half times S times r for the area as well. Let's start by drawing a diagram. We have our sector shown here, AOB. We have the angle, theta, and we have the radii marked here. So the area formula, the second formula on the right side, is half times theta times r squared. We'll use that to get our expression for the perimeter here. The area is given in the question, which is 10 square centimeters. And we'll substitute the area value here into the formula. So 10 equals a half times theta r squared. And by some rearrangement, theta is 20 divided by r squared. So we have our perimeter as r plus r, which is 2r, and r times 20 divided by r squared, which is equal to theta from this part here. So a bit of simplification, we'll get 2r, and 20 divided by r squared times r is 20 on r. So this is our final answer for part A. In part B, we want to find the value of r for which p has a stationary value. So we write our equation from the previous section for the perimeter in terms of the radius. And we'll change our value to be r power -1, and we'll move it to the top. So to find our stationary value, we need to differentiate the perimeter with respect to the radius. So when you differentiate 2r, you get 2. When you differentiate 20r power -1, you'll get -20r power -2. And moving your r power -2 to the denominator, you'll get r squared. And to find your stationary value, we need to let the derivative equal to 0. So that's what we've done here. We have 2 minus 20 divided by r squared equals 0. And when you rearrange that equation, you'll get r squared equals 10 and r equals positive root 10, the principal root. So when r equals root 10, the perimeter will have a stationary value. In part C, we want to determine the nature of this stationary value. That means whether it's a minimum or maximum value. So we do that by calculating the second derivative. And if the second derivative is positive at r equals root 10, the perimeter will be minimized. And if it is negative at r equals root 10, the perimeter will be maximized. So our derivative from part B is 2 minus 20 times r power -2. And when we take our second derivative, our constant value 2 will disappear, and -2 will come down and multiply to -20 to give 40, and then we subtract the power down to give -3. And we can write that as 40 divided by r cubed. That's our second derivative. So rewriting that, our second derivative is 40 divided by r cubed. And we want to substitute r equals root 10 into our second derivative, which we've done here. And when you do that and simplify, you'll get 1.26, which is a positive value. You can already see that this is positive without using a calculator anyway. So we can see that the derivative is positive, so the perimeter is minimized when the radius equals root 10. In the final part, part D, we want to find the value of the angle at this stationary value. We know from the question that the area is 10 square centimeters and the radius is root 10 centimeters. And the area of the sector is a half theta r squared. And we'll just substitute our values. So the A is 10, R is root 10, and we'll simplify. And that will give us 10 equals a half theta times 10. And simplify a bit more, 2 times 10 on 10. The 10s will cancel. And theta will be equal to 2 radians. And that's your final answer. Thanks for watching.